Hi, welcome back to Mrs. Thompson's classroom again today. We are going to be talking about polynomials again and looking at what their graphs look like. So we want to remember from last time the general strategy for graphing these functions. So the first thing we're going to do is look at the leading coefficient test to determine the end behavior. So that means we want to decide what it's doing to the far left and right and whether it's an generally increasing function or decreasing function, or whether it's opening upwards or downwards. So this is going to be real helpful just so we have the general idea of the direction of the graph. Then you're going to find the x-intercepts or the roots or zeros of the function and their multiplicities, the y-intercept. We can also look to see if it has any symmetry, which will help us in connecting the dots properly. And make sure once we have that all connected, if it has the right number of turning points, because if we've drawn too many humps or valleys, then we have a problem. And then we can fill in detail by making a table of values. Okay, so the first thing I want to do though this time is I want to review or maybe introduce you to a new theorem that's called the Intermediate Value Theorem. Now, the Intermediate Value Theorem helps us to find where a function's roots can be. Okay, if we have a function that we just can't factor it out and we're really not sure where they are, the Intermediate Value Theorem can help us shrink the possibilities. And this is what I mean. So here's what the theorem says. If f is a polynomial function with real coefficients and a is less than b, if f of a and f of b have opposite signs, in other words, one's positive and one's negative, then there has to exist a place where the function is zero. So let's think about what this means. We know polynomials are continuous. So if this is a and this is b, and f of a is down here, and f of b is up here, if it is a polynomial, then that means it's continuous. We talked about that last time. So I should be able to draw it without picking up my pencil. So I have to connect these two dots. Well, no matter how many wiggles or squiggles I do in between, I'm going to get a place where it crosses the x-axis. Okay, now this is a specific version of the Intermediate Value Theorem. It does apply to other functions besides polynomials, but it's very applicable here in helping us to find out whether a root occurs or not. So if a problem says, show that a function has at least one zero between 0 and 2, the first thing I need to know is state that f of x is a polynomial, which means the Intermediate Value Theorem applies. Okay, so then I go and I say, well, what is f of 0? Well, f of 0 is going to be -5. And then I find f of 2. So that's 2 to the 4th plus 2 times 2 cubed minus 5. So that's 16 plus 16 minus 5. So that's 32 minus 5, which is 27. So what I have discovered, if I were to look at the graph, is f of 0 is -5, and f of 2 is way up here at 27. So I have to connect the dots. So since f of 0 is less than 0, which is less than f of 2, there exists f of c equals 0 for c between 0 and 2. So we have a root Now that's nice. If I can't actually factor this function, if I can't find its roots, at least I know there has to be one in this interval. And if I can make that interval small enough, like maybe not 0 to 2, but maybe between 0 and 1, or between 0 and a half, or maybe between a half and 1. If I can make that interval small enough, then I can get an estimate, a pretty good estimate for where to plot that root on my graph, okay? So that's going to help us in situations where we can't calculate the roots on our own. Okay, now let's get back to graphing these functions. So here's an example. So the first thing we do is we talk about end behavior. So the leading coefficient of this particular function is 1. Okay, that's positive. The degree of this function is 4. So that's even. So because of that, I know that as x goes to infinity, the function is also going to go to infinity, and it's going to go up on the right. Okay, as x goes to negative infinity, f of x is also going to go up, because since it's even, they have to go the same direction. So I know what the far left and the far right are going to do. I know where the arrows are going to go. Okay, the next thing I'm going to do is I'm going to find the roots or zeros of the function. So I'm going to take x to the 4th minus 10x squared plus 24, and I'm going to set it equal to 0. Now this function will factor. I can make that x to the 4th and x squared times x squared. The 24 is going to be 6 and 4. And since I have a negative here in the middle with a positive on the end, they're both going to be negative. Okay. So then I can find each of the roots. So this would tell me x squared minus 6 is 0. So x squared is 6. And x is plus or minus the square root of 6. This one tells me x squared minus 4 is 0. So x squared is 4, which tells me x is plus or minus 2. So let's plot those. Here's negative 2. Here's positive 2. The square root of 6 is going to be a little bit larger than 2, right? Because the square root of 4 is 2, and the square root of 9 is 3. So it's actually going to be, here and maybe here. And as long as I label them, I'm okay to sort of approximate. Okay, then I want to find the y-intercept. So that means I'm going to find f of 0. So that's 0 to the 4th minus 10 times 0 squared plus 24. So that equals 24. So let's maybe change our values here to count by 2, 4, 6, 8, 10. That makes this top line 20. So 24 would be way up here. Okay. So I'm going to have to connect these dots. So the function's going to go up on the left. It's going to go through both of these roots because they all have a multiplicity of 1. It's going to come up to this y-intercept, and then it's going to have to come back down and go through both of these and then back up on the right. Now, this does not tell me where this maximum is up here. I don't know what that value is, so I just sort of made the hump. If I want to fill in that detail, you can go and make a chart and maybe plug in numbers between 0 and 2. So maybe I plug in a half and a 1 and a 3/2 to figure out how tall this mountain gets. I also don't have detail about what it's doing between the roots, but I do know it has to dip below because the multiplicities are all 1, so it has to travel through. So this is a fairly just a sketch of the graph, but I do know that it's going the right direction. I know that it's in the right place, and I know my intercepts and my x-intercepts and y-intercepts are all in the right location. So it gives me a pretty good idea of the look of the graph. Okay? All right, let's try another one. Now this one, the leading coefficient, to find the leading coefficient, I'm going to have to multiply these things out. And remember that they are affected by these degrees. So I'll have 2 times x squared times x cubed gives me 2x to the 5th. So the leading coefficient is 2 and the degree is 5. So it's positive and odd. That tells me that my function has to go in this direction, okay? As x goes to infinity, f of x goes to infinity. And as x goes to negative infinity, f of x goes to negative infinity. So my arrows on the graph are going to go in this direction. Then I find my roots. So I'm going to set it equal to 0. Take each factor and set it equal to 0. And I'm going to note their multiplicities. Okay, so x equals 1 has a multiplicity of 2. X equals negative 2 has a multiplicity of 3. Okay. Now, sometimes I get students ask me, well, what about this 2? Well, it is its own factor, but 2 can never equal 0, so it does not help me find my roots. Okay, so let's plot these two, negative 2 and a positive 1. Okay. All right, then we can also find the y-intercept. So this will give me f of 0. So that's going to give me 2 times 1 times 4, which is 8. So let's go and count 1, 2. Actually, let's make our scale a little bit smaller. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, with these multiplicities, I know that this one has to be a turning point because it's even. The multiplicity of 3 means it's going to go straight through it. So at x equals negative 2, I'm going to go straight through. But at x equals 1, I'm going to turn around. Now, how do I know it's above it or below it? Well, let's connect to these arrows. So I have to go down on this side. Then I'm going to go straight through this root and up towards my y-intercept. And then down towards this root. And then it's going to be a turning point and it's going to go up again. Okay, now I don't have any detail in this graph. So I might want to make a table. So maybe I plug in an x of negative 1 to get a little more detail. So I'll have 2 times negative 1 minus 1 squared times negative 1 plus 2 squared, which gets me 2 times 4 times 1, which is also 8. So let's fix this just a little bit. So at negative 1, it's also going to be at 8. So my graph is going to have to come up and then come back down. So my mountaintop, my maximum is going to be in here between negative 1 and 0. Okay? And you can pick however many x values you want to get some more detail, but this shows me the general shape of the graph. Okay? Now, the last thing we can do is we can actually be given the graph and figure out the polynomial that gives us that graph. And so what we're going to do is we're going to look at the end behavior. And because the end behavior goes in opposite directions, I know it is an odd degree. Okay? Now it says the lowest degree possible. Well, the lowest odd degree, I know this is not linear. Okay, it doesn't look like a line. So the lowest odd degree it could be would then be 3. Okay, so that means I'm going to have f of x equals some leading coefficient times 3 factors. Now, how do I find the factors? Well, I need to go find the roots. Okay, now the root will tell me the factor. So this one tells me x plus 1. Okay. This one tells me x minus 3. But that's only 2 of them, and I only have 2 roots. But I do notice something. I notice that this one here is a turning point. That means it has to have an even degree. So this x plus 1 has to occur twice in order to become a turning point. So I have f of x equals a times x plus 1 squared times x minus 3. So my last piece of the puzzle is to figure out what the leading coefficient is. Well, I do know that the leading coefficient has to be positive because of the direction of the graph. But if I can find another exact point, okay, so like this value right here looks like it's at 0, negative 1.5. So if I use that and I put in an x of 0, I'll get negative, and I'm going to go ahead and make that a fraction, negative 3/2 is going to equal a times 1 times negative 3. So that tells me that negative 3/2 equals negative 3a. So solving for a, I can get a equals a positive 1/2. So my final answer is 1/2 times x plus 1 squared times x minus 3. And that is my polynomial that matches this graph, at least the one of lowest degree. It could be actually a 5th degree, and this x plus 1 is occurring 4 times, or something like that. But the lowest degree possible that could give me that graph would be this function right here. Okay, so we can take the function and get the graph, or we can take the graph and get the function. So hopefully that helps. Get some practice at that. Comment down below if you have some questions, or if you're in class with me, I will see you tomorrow. So hopefully this helps. See you next time.